Hello, good evening, everyone. Am I audible?
Yes, Shrikar, you're audible. We will start the session in a couple of minutes. We are waiting for the participants to join. Yeah, good evening. Welcome all for 2-week faculty development program. We will wait for a couple of minutes for the participants to join. Thank you. Yeah, good evening. Welcome.
Good evening, everyone. Hope you're all having a great day so far. I'd like to start off the FDP with calling our. Yeah. I'd like to request our coordinator, Dr. Rekha of ATAL FDP, to welcome all.
Thank you, Shrika. Respected Principal Sir, AICT officials, guest speaker of today, and distinguished participants. It gives me great pleasure to welcome all of you and chair the opening ceremony this evening to 2-week AICT-sponsored ATAL FDP, a holistic approach for sustainable and smart agriculture using artificial intelligence and deep learning techniques, organized by Koneru Lakshmi Educational Foundation, Hyderabad. The main objective of this FDP is to enrich the knowledge of faculties in the field of implementing smart agriculture using artificial intelligence, machine learning, and deep learning techniques through interacting with eminent personalities from industries and academia. The knowledge sharing will improve the teaching learning process to the students and benefit the society. In the 2-week FDP, we will be covering both theoretical and practical hands-on sessions. I would like to take this opportunity to express my sincere thanks to our Honorable Principal Sir and guest speaker. They have been working with us in the beginning of the planning stage, and they are still here today for all of us, even though they are busy with their responsibilities. We truly appreciate your dedication. This training program is being sponsored by ATAL AICT, and we sincerely thank them for providing the opportunity. I hope that everyone would take the result of this program to develop smart agriculture in the field of smart applications in the field of agriculture. Thanking all. Once again, welcome all for this FDP. Now we will start with a prayer song. I request Lasya to start with the prayer song.
श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे शन्ततमहं कुञ्जरमुखं शङ्करसुतं तमिह श्रीविघ्नराजं भजे शन्ततमहं दन्ते कुञ्जरमुखं मन्तशङ्करसुतं तमि श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे कनककेयूरहारावळि कलितगम्भीरगौरगिरिशोभम् कनककेयूरहारावळि कलितगम्भीरगौरगिरिशोभं सुशोभं कामादिभयभरितमूढमदिकलिकलुषखण्डितमुखण्डः प्रतापम् शनकसुतनारदत्तञ्जलिपराचर्मतङ्गमुनिसङ्गसल्लापम् सत्यपरमब्जनयन प्रमदमुक्तिगणतत्त्वमसि नित्यनिगमादिस्वरूपम् श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे
Thank you, Lasya. Now I'd like to introduce our principal, Dr. L. Koteshwar Rao. He holds his BTech in ECE from JNTU College of Engineering, Kakinada, Masters of Engineering from Andhra University, College of Engineering, Vishakhapatnam. He was in UK for his MS research at UEL, London. He obtained his PhD from JNTUH. His research interests are computer vision, IoT, and machine learning. He has published more than 30 research papers in journals of repute and 12 in conferences. He holds 5 patents, 1 industry consultancy, and 2 books, one of them as a textbook by Taylor and Francis. He has 20 years of teaching experience in India and abroad. Currently, he is the principal of College of Engineering, KLU, Hyderabad campus. Now, I'd like to invite our principal, sir, to address the meeting.
Good evening, everyone. Respected colleagues of KLU Hyderabad. Good evening, everyone. Subramanian, AICT officials, participants, the students who have attended the Day 1 program of FDP being planned by KLH team, KL University, Hyderabad, officially known as Koneru Lakshmaya Education Foundation, Hyderabad, started its operations 5 years back. It has been a great experience in many aspects to disseminate the knowledge gained through various research experiences, through the collaborations that we have at our university. And we are very thankful for the FDP being sanctioned by AICTE ATAL scheme, under ATAL scheme. So this is really a privilege for us as an university getting FDP sanctioned by AICTE, which has considered our application in positive way and approved our FDP. It's consecutively second year that we are getting this. We are so much thankful and indebted to the AICTE team which has shortlisted our proposal. Also, we have the collaboration with the Indian Oilseed Research Organization at Hyderabad, ICAR, Indian Council for Agricultural Research, which has been a partner or a wonderful collaborator where our students and faculty are working for the last 2-3 years. Coming to the FDP and its title, it's really the need of the hour where the technology embedded into agriculture is a requirement at this moment. So the tools of AI, the tools of deep learning are really, if they are useful to the society, that will make a huge difference. In this context, I appreciate the organizers or the coordinators for their wonderful composition of title, composition of resource persons, composition of the topics that they have chosen for this FDP. I'm 100% sure that these topics will provide a lot of knowledge, a lot of updates about the technology to all the participants. And certainly this will percolate down to the students and thus to the society again. The Government of India's initiative to make this FDP both in online and offline is really a wonderful decision. Unlike last year, before last year, we have seen how we have suffered during COVID times, where there was online, every time online, that was not really reaching sometimes, I felt. But truly speaking, that efforts of conducting FDP during tough times also have impacted, have really created interest among the people, among the participants, among the faculty members. Truly appreciate, heartfully appreciate the initiative of AICTE, which is consistently working to improve the quality of the faculty and engineering institutions in the country. And due to the initiatives, many initiatives taken by AICTE, now we are providing the top quality engineering education across the country. That credit really goes to the AICTE and its leadership team. Coming to this university, KL University boasts of its campuses both at Vijayawada and Hyderabad, having an ARF ranked 27 and always in the top 50 in the country, on par with top reputed institutions in the country. Category 1 institution having 80% of the faculty with doctorates. These kind of FDPs are always boosters to their faculty members, to the faculty members of every department, both in electronics and communication, computer science, and artificial intelligence and data science, where many faculty are working in multidiscipline and interdisciplinary subjects. So these kind of FDPs, especially on latest technologies, will help the student community as well as faculty across the regions. Definitely, it will make a huge difference and motivate our students to think about the society. The purpose of education is only recognized when there is some societal impact, there is some solution to the societal problems. I'm 100% sure the current scenario where the technology is very close to the society, technology is very close to the agriculture, technology is very close to everyone in the country. I'm sure that in future, most of the solutions, most of the problems and their solutions will be through the technology. And the role players are definitely the students, of course, the faculty, and thus the university, and thus the country top leadership. With this, I once again congratulate the coordinators and I wish them all the very best. And I wish all the participants a very best for their coming 10 to, I think, 11 days program. Whatever online and offline, I hope they will not miss a single day as the coordinators have identified excellent speakers, excellent resource persons with their vast experience in their areas without compromising on the quality. They have identified the marvelous resource persons. I wish the participants go with a excellent satisfaction of knowledge gaining as well as real-time experience, all-round experience and exposure to take it to the down level, next level, that is our students. So with this, I thank the organizers for giving me this opportunity. I take this opportunity to thank AICTE and I wish all the very best for this program. Thank you and good evening.
Thank you, sir. Now, I'd like to invite Dr. K. Ramasubramaniam, coordinator of co-coordinator of KLEF to brief the session.
Good evening, everyone. Our schedule is from today, that is 5th September to 16th September. And we have two
Sir, you are muted. Kindly unmute.
Okay, sorry. So first week is online lecture schedule. Here we have very good resource persons. Today, Dr. Chunduri Sharada, who will be talking about principles and practices for modern smart agriculture. Tomorrow, 6th September, Mr. Sam Santosh, who will be talking about role of recent technologies in precision agriculture. Sounder Rajan, on Wednesday, he'll be talking about role of artificial intelligence in agriculture, technical transformation. Dr. Mudassir Rafi, on 8th September, he'll be talking about application of ML and computer vision in smart farming. And on 9th September, Dr. Chandrasekhar from IIT, he'll be talking about deep learning and its application in agriculture. And 10th September on Saturday, Dr. R. Radha, she'll be talking about IoT-driven agriculture. This is our online lecture schedule, and every day it starts from 7 p.m. to 9 p.m. And the next week, that is from 12th to 16th, we have offline session. Offline session will be conducted in our KL University, Hyderabad campus. On 12th, Dr. Ramachandram, he'll be talking about IoT-enabled crop field monitoring. And Dr. Teja, on 13th, he'll be giving a live demo about the role of AR and VR in agriculture. Then Dr. Sandeep, who will be talking about TensorFlow, a practical exposure. Then Mr. Saravana from Chennai, he'll be talking about and he'll be giving a live demo, the role of IoT and smart sensors in the field of agriculture. And Dr. Mahesh Babu, he'll be talking about metaverse in precision agriculture. Mr. Uttam, he'll be talking about, or he'll be doing a case study to understand the role of AI and ML in agriculture. And on 16th, Dr. YVS Sigaj Prasad, he'll be talking about teaching learning practices. This is our 2-week schedule. And I think everyone knows, according to AICTE norms, we need to have minimum of 85% attendance. I hope you will enjoy all the sessions and get good information. Thank you. Now, speaker, you can introduce about today's speaker.
Thank you, sir. So we have with us today Dr. Sharada. She is a PhD in agricultural statistics in ICAR, which is Indian Agricultural Statistics Research Institute, working as principal scientist in Indian Institute of Oilseeds Research. She is having 23 years of experience and is specialized in nonlinear regression modeling, time series forecasting, ANN, ML, and bioinformatics. She published around 60 research papers in peer-reviewed journals and 30 popular technical articles, book chapters. She attended around 40 conferences and handled 22 funded projects as principal inspector and co-principal inspector. Now I'd like to invite Ma'am to please take over the session.
Shall I stop sharing my screen?
Yeah. Am I audible?
Yes, ma'am. You are.
Yes, ma'am. Yes, ma'am. You're audible.
Can you see my screen?
Yes, ma'am. Your screen is visible.
Yeah. Thank you. Yeah. Good evening to all of you. And at the outset, I would like to thank Principal Dr. Koteswara Garu and course coordinators Dr. Raika and Dr. Subramanian for giving me this opportunity. And today I am going to speak about the principles and practices for modern smart agriculture. Before I am going to the actual my presentation, I just would like to brief about our institute. Our parent institute is Indian Council of Agriculture Research, which is established in 1929. So within 7 to 8 years, it will be completing 100 years, and it is one of the largest national agriculture research system in the world, and it is an autonomous organization, and we comes under Department of Agriculture Research and Education and Ministry of Agriculture. So it is an apex body which coordinates, guides, manages research and education in agriculture, horticulture, animal husbandry, and fisheries. And we have 101 ICR institutes under this ICAR and 71 agricultural universities across the country. And we have a beautiful system called All India Coordinated Research Project System. it actually works. Whatever technologies emanated from these 101 ICR institutes and agriculture universities, all these technologies will be tested in the all over India across through this equip system, so that the technology will be tested across India. For each crop, we'll be having each equip, separate equip will be there, and that will be handling all the technologies emanated from the agriculture universities and ICR institutes. This gives us a good confidence that the technology emanated will be working across the India. So that is, we are having this sort of system. So all our centers are placed across the India. And from, if we see from 1950 to 51, our food grains are increased by 5.5 times, and even horticultural crops are 10.5 times, and fish around 17 times, and milk around 10 times. These are all happened because of this our ICR system working and striving hard for improving our agriculture growth. And I would like to tell about the Krishi portal. This is a portal which gives, it's, we can say it is a face of ICR. Here you can see all our technologies and what are the videos developed for the agriculture farmers, and the mobile apps, and whatever all publications, and even GIS research work, and all these were all kept under this Krishi portal. And if you type in Google Krishi portal, you can get this website. You can see what are the achievements or technologies we have developed through this portal. And I am working under Indian Institute of Oilseeds Research, and basically we work with the annual oilseed crops. In India, 9 oilseed crops are mostly grown. Here we can see this is the groundnut crop, and mostly all you will be knowing, and this is mustard, and this is soybean crop. All three we have separate institutes. Groundnut Institute is in Junagadh, and mustard, rapeseed and mustard institute in Bharatpur, Rajasthan, and soybean institute is in Indore. And other 6 crops, like this is sesamum crop, and sunflower and safflower. Safflower you must be knowing, we call it as in Hindi kusum or kusuma in Telugu. This is like safflower oil will get, that is a blended oil of safflower, and the castor, this is the castor crop, and nizer, we call it as this nizer and linseed. They both are having the medicinal properties. Linseed is nothing but flax. We'll be taking the flax oil capsules for omega-3. So all these 9 oil seed crops are we are dealing. So we have incorporated all the information about all these 9 oil seeds in a mobile application called Oil Seeds at a Glance. You can download from the Google app, Google Play Store. And for example, we will each crop information is given, that what is its scientific name, what are the local names we can call in the various parts of the India, and what is the importance of the crop, and what are the major growing states and seasons, what soils it need, what climate is need, how much seed rate, and what seed treatment it required, and what is the spacing is required for the sowing, and what is the exact sowing time. Like all the package of practices we have given in this app. You can go through this. You will get all the information for all these 9 crops. And coming to my present institute, we comes under ICR. Ours is Indian Institute of Oilseeds Research, and it is established in 1977. Now, as I already told, we are dealing with these 6 crops: castor, sunflower, safflower, sesame, Niger, and linseed. And the major mandate is we work on basic and strategic research, so to augment the productivity and oil content and the quality of these all 6 crops. And another most important mandate is we we are developing a network of information management, so that for the research and development strategy, this knowledge management network will help us to make the policy frameworks. And as I say, I already told, we have the ECRIP system. So through this ECRIP system, we are coordinating the applied research at national and regional issues, which are located to develop location-specific varieties and technologies. After testing in the ECRIP system, these varieties or any technologies to release it to the nation or region-wise based on their performance. And another, the most important thing is dissemination of technology. Whatever technologies developed in the institute should be reached to the stakeholders. Our stakeholders are farmers. So this dissemination of technology we are making through the demonstrations, field demonstrations, exhibitions, and making the awareness campaigns, making the like print media, and making videos, how the technology has to be used, whatever technology is developed. And also we are doing capacity building, so that the farmers and other other line departments can get the awareness about the technologies. And this I just want to show. Recently, we completed this project 2 years back. This is, as I shown you, the castor. Castor is a important industrial crop. It is badly affected by this gray mold disease. So this disease is very short period disease, and we cannot model through any statistical means or statistical models. So and it is highly weather dependent. So what we have done is we have collected the data, half an hourly data with the sensors. We have temperature, leaf wetness sensors, and relative humidity sensors. And we developed this data was we will be collecting in the through web server, and the disease data we collected manually. And by integrating the weather data and disease data, we have developed the weighted regression in indices models. And along with the some decision rules, we have developed a decision support system for the gray mold and castor. This we have developed with the help of CDAC. So tomorrow you will be having lecture of Mr. Sam. He will explain in a much better way what are the sensors they used. And actually these sensors, what we have done in, we have put in the farmers fields. So we have got the real-time data in this. And we have developed a mobile app for the castor gray mold in Telugu, because this disease is very much confined to the southern India and mostly the Andhra and Telangana. So to facilitate the farmers, we developed an app in Telugu. Here we have developed an expert advisory system that gives here the back end of this expert advisory system. We use the machine learning algorithm that we actually developed the three multinomial logistic models and decision trees and random forest, and we compared, and we have found that random forest algorithm has better performed for giving the good results. So we have in the back end we have put this random forest and we try to predict the risk of the gray mold disease. The user should give the what is the some information, and based on the information he submitted, we can get the advisory. So here we have taken most important 7 attributes, and based on that we have backend we have run the random forest model, and that gives the advisory. This is some of the IoT and mobile application aspects we have done recently. Now coming to our smart agriculture. The agriculture, by definition, it includes agriculture as per se and horticulture. Horticulture is nothing but the culturing of vegetables and fruits, flowers, that is called as horticulture, and animal husbandry and fisheries. All these are comes under the domain of agriculture. And if we want to add our technologies, the smart technologies, that should be a self-monitoring analysis reporting technology. If we take into the agriculture, so that it helps the farmers to reduce their drudgery, or it improves the livelihood, that would be our goal. So in the basically in my presentation, I am only restricting myself to the agriculture only, and in agriculture there are sub phases or stages we can call, like this is pre-sowing and pre-harvest, and that means before harvesting or while during doing the farming, and what are the post-harvest. These are the 3 stages of the agriculture. And even these technologies like IoT, sensor, software, networking, or computer vision, or machine learning models, or deep learning, or any other technologies, recent advanced technologies, drones, blockchain technology, or any ICT technologies, even design and fabrication of the machinery, all these technologies will help in the agriculture in either individual or combinedly in these aspects. So I'll be explaining with the examples from the literature, so that what is the data they used and what are the methodologies they used to or technologies, newer technologies used to make the life easier for the farmer, and to get the accurate or optimum yields. So I'll be presenting from starting of the I'll be showing the what is the farming cycle, and in what are the stages in the farming cycle, and from each part of the farming cycle, I'll be explaining with the examples what is our recent ML or AI technologies will be useful for the farmers, how the data should be collected, and what are the technologies like image analysis, ML or DL algorithms they used, and how it will be helpful for the farmers for making the for saving their time and labor. So usually this farming cycle begins from the land preparation, and it goes to the after land preparation, they sow the seeds, and irrigation is nothing but the watering of the field. So the irrigation is required for the growth of the crop, and irrigation fertilizer is for the nutrient supply for the crop. And the most important part is the crop will be affected by different diseases or pests or weeds, or this should be managed thoroughly. Otherwise, the losses will be innumerable, and sometimes the whole crop may be lost. So this is the most crucial part in the crop cultivation. And finally, the harvesting. Here, the harvesting, what we have to see is what could be our yield prediction, based on that the farmer can decide what is the yield of his crop and where to sell, and all marketing aspects we can see in the harvesting part. So before the farmer going to means initiating the cultivation, the one aspect is the crop selection. Usually farmers, what they will do is, based on the neighbors influence, neighboring farmer is taking up this crop, so we can also take up, or based on the previous prices of the market, they will tend to take the crop which is having a high market price in the previous year, or if he is having the saving of the seed of the previous crop, they will take up the crop. But in such cases, their decisions may go wrong, because if the same crop is taken up over the years, the soil nutrients will be exhausted. So the crop rotation means after taking the same crop for 1 or 2, 3 years, they have to again regenerate the soil with the like nitrogen, phosphorus, potash, and all those. With the other crops like pulse crops, it gives the nitrogen. So such sort of crops they have to take up. So based on the properties of the soil, what soil health, they have to take the crop. So one example I'm explaining here is they have made an ensemble model by taking the data for the soil depth, and what is the texture of the soil, and what is the pH, soil color, then their permeability, and the drainage also is the most important. If it is the soil is saturated with water, so it lodges the crop. So the drainage system is also an important, and what is its water holding capacity, and what is the erosion rate. All these are the all these soil characters are required to take up the crop, and what is the crops they have taken previously. All these characters they have considered for developing the model. What they have done is, they have taken 4 different models, like random tree, nearest neighbor, and nearby base. All these based on the majority voting of these models, they have made some rules, and they recommended the crop, which crop they can select, they can select. So this is one example. Based on the soil characters, we can select the crop. And another example I would like to tell, based on the weather parameters and what is the crop requirement, they have taken the historical data of the rainfall, temperature, slope, humidity, and soil moisture. So like 30 years, 50 years data they have taken, and they calculated the monthly average of each parameters, and based on the longitude and latitude, they have fetched the data for the only Karnataka, because the data and the crop requirement they are chosen only Karnataka state, and the final data set they used for the pattern matching method. So when the user gives the district and the month of the year, it gives the which crop can be raised. So the first what they have taken is they have taken the reduction techniques and seen what are the variables are important. They have ranked the variables of importance, like rainfall is the first, and so on. So first they have started what is the rainfall required for the crop, and based on the data they matched based on the latitude and longitude what the user selected, they matched with the system, and based on that the crop was selected. So this is one sort of example for the crop selection. Now, and another aspect, before once we have selected some crop and we have to get the seed, we have to see the purity of the seed. This purity of the seed is very much important at the seed this seed purity was tested by the seed certification agencies. All these seed companies should undergo this seed certification before moving their seed lots. So usually farmers or any labs, they test through the specific gravity method, and this paper towel method is testing for germination, and which is very time consuming. So these people, what they have done is, based on the image analysis of color, shape and texture of the rice seed they used, and they developed a rice seed germination evaluation system. They used the ANN model with 18 nodes and 18 attributes and 13 nodes and 2 layers. And they used, you can see the data set, they used around 34,000 images. So why I am explaining all those things is, what is the data we required for achieving our objective. So the proper data only gives us the proper output. So before planning your research work, you have to know the domain, knowledge domain should be there. So you have to thoroughly discuss with the agriculture scientist what are their requirement and what they are expecting. So based on that, you have to plan that. And this image analysis or any DL algorithms, they require lot of data. So to explain that, I have just given this example. And this is just based on the as already told, this growth test for the test is conducted to test this genetic purity, and this based on the human vision, this is very subjective, whether the germination percentage is good or not. So what they have done, just by using the flatbed scanner, they have taken the digital images and they have done the discriminant analysis. And the seed purity will they have achieved is 99.2%, and even 93% for the shape parameters. So with this, we can save the time without going to the actual germination tests. And once the seed purity was tested and seed was selected, and the sowing methods. Sowing is nothing but we will put the seed in the field. So this the sowing, the seed sowing is mainly dependent on the type of the seed and what is the distance should be from plant to plant and how much depth we have to keep. All these matters for the good germination in the field. So like here we can see the different seeds. Some seeds are very minute and some may be with like corn seed or maize seed is bigger, but the seeds which are very minute, they require it is very difficult to sow precisely. If we are putting lumps of seed in one place as a hill, that germinates more number of plants. It gives a crop competition, and the nutritions will be shared by the number of plants. So this should be avoided. So we should keep in mind the required number of seeds should be placed in the hill, and the distance should be proper, and depth also should be proper for germination of the seed. So simple seed sowing mission they have made, so that these all sort of seeds can be sown in the field with this. So this type of machines also, mechanical devices also will helps the farmers to reduce the labor or drudgery for sowing these small seeds. And another I want to show this robot for sowing the seeds. What it will do is it digs the hole in the field, and based on the valve controller, it sow the seed, and it levels after that. So with the required depth, the seed will be sown, and this can be controlled with the Android app. So see, this sort of robot sowing methods also can be thought of. And another one is after sowing the seed, the seeds will be germinated, and the field will be covered by the crop or canopy, we can call it is. And based on the canopy cover, we can predict the yield. Just before harvesting itself, we can predict the yield. So what is the percentage ground area covered by the crop is called canopy. So so this based on the major indicators are what is the land use and what is the land degradation, and we can use for this as a crop yield prediction. So this we will be estimating the plant emergence and plant density. All these yield estimations will be usually manually done with the field surveys, field crop cutting experiments, or based on the remote sensing data. But using our new advanced technologies, we can predict the crop canopy without doing the field survey. And this crop, here what they have done is they used high resolution cameras, and they want to predict with the different plant densities. As I told you, the manual counting method is very labor intensive and time consuming and difficult in large areas. So this algorithm, it identifies the rows and successively detect the connected components, and the green pixels corresponds the plant used as these green pixels are used as the features, and they trained the ANN to estimate the number of plants in the each row. So they found that only 12% error occurred in the estimating of the wheat plant density. In the early growth stages itself, they can predict how much yield can be got from this wheat field. So this is this helps the farmers to plan their marketing and all. Another one is they used UAV digital images, and the CNN algorithm, convolution neural networks, they use for the counting of the planting corn plants. So what they have done is they have taken 50 images using this UAV, and they use the CNN for the classification purposes. The average difference they found that average difference between the manual and automatic counting is only 7.3%. So if they used 45,000 plants to assess the prediction accuracy. So this is one sort of image analysis and CNN we can use for the plant counting. And even at the different stages also, growth stages also, we have to monitor the field so that what is the yield estimation, or what is the crop growth. We have to monitor at every level of the growth stages. This is for one example they used for the maize. They have taken the 2 critical stages, the emergence and 3-leaf stage. This 3-leaf stage is when the 3 leaves emerges, then the flowering starts. So that called silky stage. So this is very crucial stage. How much, how many plants they have they come to the 3-leaf stage, and so that they can estimate the yield, how much percentage is started. This days to flowering they call. How many are under flowering? That gives us the crop estimation. So they used digital cameras as kept in a 60 degrees angle, and they've taken the images. The camera acquired images 8 times per day and every hour from 9 to 16. And they have seen they have the method they used has given 96% of accuracy. So we should be why I'm explaining this, how much accuracy they have got while planning the our research work or experiment. We should be clear enough that how much accuracy we should get. With the how much accuracy we will be close to the reality. That all should keep in mind before planning the experiment. And another most important thing is in the crop or in the field, unwanted plants. Weeds means unwanted plants. They grow in between the rows. The weed seed will be along with the soil, and when we apply the nutrition or we apply the irrigation, these weeds also emerges. These weeds also compete with the other nutrition, irrigation, water, everything with the main crop. Like here they have taken 2 fields, cucumber and an onion, and they have captured the video and they reconstructed the plants, and they they extracted the features and used CNN and ResNet. Like they capture the video from the field and extract the features with using the OpenCV, and they have done 3D reconstruction of the plants, and they trained with the machine learning model for weed detection, and these features are used for the CN as attributes for the neural network models, and they like for the external data set, they got the 86% for ResNet and 88%. So for the cucumber, they have got 84% of the accuracy, and for onion it is 90%. So for other models, they took 6 hours, but the time training time it has lessened. It's only 3 minutes. So for the evaluation of the model, we have to check what is the accuracy. If any new data set was given to the model, how much accuracy it is giving, and what is the time taking for the giving the output. So all these aspects we have to keep in mind while planning our experiment. And in soybean, they used again CNN. They used UAVs for the capturing the images. So these unwanted plants, as I already told, it causes economic losses, and even in difficulty in the harvesting. So knowledge of there are so many different types of weeds will be there. Some are broad-leaved leaves, some are like grasses, and all are dicots, they call broad-leaved leaves. Monocots like rice, like only it mimics rice, but it is not the rice. So that is called monocots. All these sort of different types of weeds we have to identify, and based on the weeds, the herbicides means nothing but it's a chemical to kill the weeds, but it protects the main crop. So these herbicides, what herbicides they should use, only with the identification of the weeds only we can say which herbicide and what concentration we have to use. So all these will be taken care of in the crop cultivation. So directly with the human means this identifying these weeds also is very difficult, because sometimes they mimic exactly the plants. So the human eye is become subjective. If we use the this image analysis and deep learning techniques, we can exactly get the what is that weed, and based on the weed classification we can use we can advise what is the herbicide and how much how much doses we have to give to kill that weed. So they have used convolution neural networks, and they compared with other machine learning. They like support vector machines, AdaBoost, and random forest, and they have got the classification has got 98% in distinguishing between the broad-leaved weeds, grass weeds, and between soil and soybean plants. So all these they have classified with the 98% accuracy. And another aspect in the crop cultivation is soil moisture prediction, when to give the irrigation. it is one of the main factors for the agriculture production, and a precise prediction helps us the rational use of management of water resources. When to give the irrigation? If we are giving excess irrigation, excess water, sometimes it larges the crop and loss will be occurred. So the precision is required for irrigation. So how to predict the soil moisture? So based on some models that developed based on the meteorological data and soil moisture, they have taken the 4 years period and taken the daily average temperatures, air pressure, and relative humidity. All these aspects have a bearing on the soil moisture, and what is the wind speed, and what is the average surface temperature of the soil, and what is the daily precipitation, what is the rainfall. Precipitation is nothing but rainfall, and this all these aspects have the impact on the soil moisture prediction. And even in the soil moisture data, what they used is average mass, water content or water holding capacity of the soil at 2 depths they have taken in the farmland. So they used deep neural network regression with multi-hidden layers, and they compare with the other machine learning algorithms. Here we can see the mean absolute percentage error is very less when compared to the all other algorithms, machine learning algorithms they have tried. So one of the most important aspect is soil moisture prediction, which really saves the resources. So the one more example I would like to show here is based on the color of the soil. They have predicted the what is the soil moisture prediction, and they have taken 6. There are several classes of soils. The soil scientist can tell the different types of soil types, and what is the soil composition for the different like how much percentage is clay, how much percentage is sand, how much percentage it is loamy. All these based on that proportions the soils will be classified. So what they have done is based on the color of these different types of soils, they have used these different images, the extracted RGB values, and they used that as the attributes for predicting the soil moisture. And they compared two models like this multi-layer perceptron neural network model and support vector machines. And what they found is support vector machine regression has given good prediction than the MLP, and they have seen because it ensured the global minimum. So here I would like to tell how to get our parameters like globally converged. We should take care of what are the method used for the iteration, like steepest descent or Markov algorithms. All those we should keep in mind, and to get the global minima, and we should keep training the model for number of times, so that every time we train the model, it should reach the global minima. Till that time, we should try the model and get the good prediction model. And after the soil moisture prediction and how we should give the irrigation. Here, this is they have used several attributes to get to give the irrigation. Like they have captured the vegetation, what is the present stage of the vegetation, and they have used sensors for the present weather conditions in microclimate, and what is the weather conditions through APIs, and the soil moisture content also they have collected using the soil moisture sensors. And apart from this, they also integrated the satellite imagery of the plant of the crop using the satellite images. So all these they have transmitted through a gateway to the cloud server, and they used machine learning algorithm for the classification of prediction, and this based on the prediction it again sent to the farm pumping device. This IoT device will based on the output given through the given by the machine learning, it will decide that how much time or how much volume and how much pump speed and what are the field zones it should irrigate. All that will be decided based on this IoT device. So here we can see this can be remotely controlled or visualized. What is the crop condition and when to irrigate, whether we should give the flood irrigation or sprinkler irrigation, and what drip irrigation, how much amount or volume of the water the crop requires. All this can be precisely given, but the lot of data they have integrated here. So this work has taken all the aspects like the vegetation and microclimatic conditions, macroclimatic conditions, and even soil moisture, and what is the satellite imagery or NDVI indexes. All these they have integrated and they have modeled and classified. So they have got a good accuracy, and this all they have deployed in the an IoT device so that it gives the irrigation decisions. Shall I continue, madam?
Yes, madam. If you want to take a break, you can take a break now.
No, I can complete.
Yeah. Okay, ma'am. Then please carry on.
And after what in the crop cultivation, we have seen what is the how to select the crop using the advanced technologies, and how the seed purity has to be checked, and what is the seed germination rate, and how the sowing has to be done, and how the canopy has to be predicted, and based on that how yield estimation was done, and what is the how weed control can be done with the prediction of the unwanted plants in the field, how we can detect with the image analysis and neural network models, and what is the how precision irrigation can be given. And apart from all those things, the soil based on the soil health conditions, there may be nutrient deficiencies. Here they have given a review article about the what are the nutrient conditions, what are the methods used for the predicting that nutrient deficiencies. Now, like the crop requires major nutrients like nitrogen, phosphorus, and potassium, and then they require in major quantities. And secondary nutrients they call the calcium, magnesium, and sulfur. And the micronutrients are zinc, boron, copper, iron, molybdenum, etc. All these nutrients are required for the better crop growth, vegetation development. All these nutrients are required. So when the nutrients are deficient, the leaves will become yellow. That is called chlorosis. We cannot differentiate between whether it is due to the pest or insect pest like sucking pest like grasshoppers, small hoppers will be there, and whether it is due to the diseases, fungal diseases, or whether it is the nutrient deficiency. It is there again is the subjectivity of the human eye will be there. So when we use this imaging methods, we can accurately distinguish between whether it is a nutrient deficiency or it is due to the pests and diseases. So this nutrient deficiency prediction is also one of the most important, because many of our soils are zinc deficiency or boron deficiency. Many rice fields they are zinc deficient. So rice leaves will become yellow. We cannot distinguish whether it is a sucking pest or hoppers. The rice is mostly affected by the brown plant leaf hopper, and these we cannot distinguish. Sometimes even though we do the pesticide spray, that cannot be, the chlorosis cannot be controlled. That means we have judged wrongly. If we use this imaginary image processing methods, we can accurately predict that which is whether it is a nutrient deficiency or due to the pest. So coming to the pest management, the most important aspect of the crop management is this pest management, which causes the yield losses. And pest is in the broad sense, pest can be defined. It is a disease, diseases, or insects, or microorganisms which causes the yield losses. We can call it as a pest. Even weeds or small animals, rodents, like that also defined under the pest. Nearly 10,000 pests are there, and 30,000 weeds, and 1 lakh diseases, and nematodes, like it is some like earthworms sort of things, nematodes. These are of 1,000, and so pests are considered as a major pest, major culprits for the decreasing the production in war. Like 1/10 of the world production was destroyed by these pests. Here we can see the how much monetary loss we are getting due to these pests. The highest is cotton. Cotton is affected by a number of pests like bollworms, and it causes heavy losses because it is a commercial crop. You can see how much production is lost and how much monetary value can be estimated. So this control of these pests and diseases are at most important for the crop cultivation. So the majorly farmers, a lot of research has been put in for the crop protection for these pest management issues, but there is no proper flow of the information from what is done, the research done in the lab, and it is not reaching to the farmers. And it is, of course, it is also not possible to reach each and every farmer on time. Unless the farmer has not taken proper steps in time, the crop will be lost. So fast and on-time support is needed to protect their crop. So large gap is existing between the knowledge generation and dissemination. So all these can be avoided or can be overcome by this image analysis, AL algorithms, cloud services. So we can develop a platform so that the farmer can identify the pest or diseases just by uploading a photo and receives the corresponding advisory within no time. So the pest management is one of the major aspect in the crop cultivation. It has a like this image analysis and AI and cloud services will help the farmer in time to get the proper advisory and to protect the crop based on the advisory. What is that pest? How much? What pesticide they have to use? If that sort of advisory we can deliver to the farmer, that will boost the farm production, and that in turn increases the livelihood of the farmer. So I already told the vast research work has been done, but it not translated into the final product to reach the farmers. Lot of we can see lot of research work was done for the identification of these pests, diseases. Millions of papers you can observe, even with the image analysis and AI algorithms. But all these were not finally translated into a final product so that it reaches the farmers. And very few mobile apps are developed for the flowers identification, disease identification, pests. But it is only for professionals because it is always in the English language, and it's not farmer friendly. And some mobile apps are available like Plantix, Croptix, and this is vegetable pest identification. There are mobile apps, but the information in local language which because all these are in English, it limits the farmers to adopt the these apps. So this is one of the major area the researchers can concentrate for identification of the pests and diseases, and develop an application by deploying the whatever model you developed with the image analysis and deep learning techniques in the mobile app, so that the farmer can use the application by just uploading the photo or image to the application and get the advisory. So just I would like to give there are many number of open repositories for the plant diseases and pests. Image repositories are there. You can try with these repositories. The data can be downloaded, and you can try with your AI algorithms, deep learning algorithms, and see how much accuracy we can get, and how the your model can be deployed and make into an application that can reach to the farmers. So I already told lot of papers, research work you can get. These are some I have given. There are a lot of reviews you can see in the image analysis and pest identification or disease identification. But all these, they stop here only. It is not translating into the final product. We never seen the farmer is using the apps or this output is transformed into an application so that the farmer can use. So what is my request is, you the whatever research work you take or whatever project you are taking, that should be the output should become an impactful outcome, so that the farmer can utilize your efforts or your outputs you generated from your project. Here we can see what are the different algorithms they use for the identification of diseases and pests. Like they use K-means clustering, then for extraction, they used Otsu method for the features, and they used a Gabor filter for feature extraction and used ANN, and they used SVM and self-organizing maps, and even fuzzy logic, and recent methods like AlexNet, so many other network models they used. And you can see here the number of images they used for the identification of the pests and diseases. So we need lot of images. The most important part is to get the reliable data and real data, so that the model can be replicated and used for the farmers' benefit. And finally, the once all these cultivation management aspects are done, another thing is yield prediction. How much yield of the farmer will get? That is also one major aspect. Here, with the human, human estimation is very laborious process. So if we do with the image analysis and deep learning techniques, that will save the time, and that will save the time. So here what they have done for the wheat, in the wheat field, they have put the cameras, and these RGB cameras, it will take the images, and this spike data set they have taken, and like image acquisition, and they pre-processed and made the final spike data set. They fine-tuned and they used the RCNN, and they trained with the spike CNN model. Here we can see the 94% accuracy. They have taken the 10 wheat varieties, and with different fertilizer treatments, what could be the yield for each variety, and with different types of fertilizer treatments. Based on that, they can optimize which variety to be recommended for the farmers, and what is the fertilizer dose they can. They can recommend for the farmers to get the optimum yield. So this experiment, they have shown how the yield prediction can be done with the image analysis and convolution neural networks. And another one is they count the fruits on the horticulture field itself, so that they can predict the yield, and they plan for the market. So here, what are the parameters they have taken? The whole image, what is the pixels, number of pixels of the whole image, and what are the number of pixels belonging to the fruit, and number of fruits based on the image. They have extracted the number of fruits as one feature, and how much foliage. Foliage is nothing but the green leaves. Foliage there, and all these features they have taken, and they have taken the actual yield for apple tree, and they have predicted what could be if these are the features. They use these features as the attributes, and the number of actual yield of the apple tree as a dependent variable, and they use the back propagation neural network models. Here they can the main difference they can found is very so very accurately they have predicted the yield. So this sort of application also is very useful for the horticulture gardens, like because all these are commercial fruits or commercial gardens. they require more accurately what could be the yield and what could be the market for the marketing fruit industry. So up to this, I talked about what is in the field, what is crop cultivation, what are the aspects we can take further, we can support for the farmer through our image analysis or deep learning techniques. And even in agriculture research also, they need the research, all other biological scientists, they need our support for their for progressing their research. So some of my contributions for the agriculture research, we have established a castor core. Core is nothing but among the we have a castor gene bank. This gene bank contains around 3,000 accessions. Accession means the breeder, they will collect the different, like suppose in castor, they collect the different castor plants from the different locations all over India. Even for exotic collections from outside country also, they get the those plants and they preserve in the gene bank. So this why they are taking this, the for getting the different variation of the gene of the plants genotypes. So if the variation is higher, we can get the better hybrids. So for that purpose, they develop the gene banks. Like we'll be having the rice gene bank or wheat gene bank. For each crop, they preserve the different plants. They call it as accessions, and these will be preserved in the gene bank, so that whenever they evaluate the plant, what is its plant height, what is its quantitative traits, how many number of seeds it is giving, or how many number of fruits, all this they will be documented. And if somebody wants to do for the breeding of this any crop, like for example castor, they will see which traits they want to, traits means characters they want to incorporate in their breeding selection, in their development of their variety or hybrid. Based on that, they will select the that genotype or accession from the gene pool or gene bank, and they will do the improvement breeding techniques, and or they will cross the different plants to get the hybrid. So for such research activities, these gene banks are helping. So what exactly is these gene banks are having 3,000 accessions. Suppose wheat or rice, they will be having 11,000. In thousands of accessions are there. But we cannot go on saying which is our required accession or which required plant genotype we need. It is very difficult to see each and every accession details. So what they need is, we have to extract some sample, that is they called it as a core, so that all the variation exist in the gene bank, all in the 3,000 accessions should conserve in this core. So that is their one of the objective, so that they can see this core. Based on the core characters, they can select. If they want many accessions, such sort of accessions, they can go back to the gene bank. That is the idea. So what we have done is, we established a castor core. Out of these 3,000 accessions, we have come down to 165 accessions, so that all this variability which is existing in the 3,000 accessions exactly we can get in the core. So for that, what we have to do is, we have to group or classify or segment our accessions, so that between the groups, it is a maximum variation should be there. Within the group, there is minimum variation should be there. So we have used so many clustering techniques, and we used the self-organized neural networks model also for segmentation. We found that the self-organized neural network was model was grouped the gene bank accessions more accurately, and from the different groups, the what this SOM has given us, from there we have randomly picked up the accessions, and we have evaluated with the different evaluation metrics for development of the core, so that the variation conserved in the core in the gene bank should be exactly reflected to the core. This is one aspect we have helped in our breeders. And another one is they will be developed. Another one is we have developed a selection index for selecting the superior genotypes. They will be doing the breeding, what you call, develop the varieties, or by crossing the different plants, they will be developing the hybrids. So you may be knowing the first, when we hybrid or plants are crossed, we will get the F1 generation, first filial generation or first generation. So a lot of plants will be generated, lot of data will be generated. We cross the plants. So among that, which genotype is having the superior characteristics of these both the parents, that is very difficult, because they are taking different number of characters for consideration. So how to see, suppose for if they are taking for the plant height, they will if they see what are the generation material, the material generated in their crossing programs, only per plant height they can select some few plants, and only for a number of capsules they can select some other few plants. But if they want to consider all the characters simultaneously, it is very difficult for them which character we have to take as a first character, or which ranks first, which is the important character. That is very difficult to get the superior genotypes, to select the genotypes by simultaneously considering all the characters. So what we have done is we have done the principal component analysis. So and generated an index based on the Eisen values and Eisen scores. This gives us an index, suppose, which is having the higher index, we can select those genotypes. It gives all the maximum positive traits or positive characters in that genotype. This is well recognized in the breeders, because it is very easy for them to select simultaneously by considering the multiple characters. They have this used for castor, sunflower, safflower. They'll be using multiple shoot and root characters. So for judging the superior genotypes, they are using this selection index. And I have used this SVM classification and hidden Markov models for prediction of microRNAs. These microRNAs are important in the gene perspective. Castor genome is having nearly 48,000 contigs. Contigs means it's a DNA what you call pieces. So from that we have to select this, predict the miRNAs without any base mRNA. So de novo means without any base. Or suppose if we are having some one sample or miRNA, we can match that and get the miRNAs. But de novo means without any base, based on the hidden Markov models, based on the probability, we have predicted the miRNAs, and based on the SVM classification, we have predicted which is the, maybe the using the Markov models, we may predicted the false also. false miRNAs. So using this SVM classification, we have classified what is the pseudo miRNA or false miRNA and what is the true miRNA. So in these aspects, I use this machine learning algorithms. Similarly, another aspect is varietal identification. So this for a varietal identification, this MNN analysis and deep learning techniques will be very useful. There is a there is an act called Plant Protection of Plant Varieties and Farmers' Rights Act. For India, this is they will call as PPV and FR Act, and even internationally there is a the same committee will be there. What is their actual motto is, suppose the farmer is growing from the years together their variety. So for locally, they will be having the traditional varieties. So these traditional varieties should be protected. So what they will do is, whether suppose a farmer registers the to register that farmer has a traditional variety which is growing from the generation together. If they come to this committee, they say the farmers tells that this is our traditional variety. So they have to test whether really it is a traditional variety or it is something it is a mixed with the other already varieties developed. So what they have done, they will do is a dust testing. So whatever variety they have brought or genotype they have brought, it should be distinct and it should be uniformly express its expression, and it should be stable over the generations. So based on the morphological characters or biochemical characters, or for these characters will be defined for the individual crop. Like castor, they will be defining some characters. If these characters are met, this we can take it as a this can be registered. But this is very manual, with the manual and labor intensive, and there is a subjectivity will be there, and quantitatively it will be very much imprecise. So if we do the image analysis, it replaces that laborious manual inspection and with cameras, and if we precisely extract the color, shape and texture measurements, we can exactly tell whether it is distinct, uniform or stable. So they have done 2 case studies, groundnut and rice. So these image features they used for the identification of the pod varieties and based on the pedigree analysis. They have taken the 20 groundnut varieties and around 2000 seeds, and these they have defined the 6 dust characters. They call it as characters. If these characters meet the requirement, and they call it as a distinct variety. So what they have done, they use just a flatbed scanner, and they have taken the images of the front side of the pod, and they extracted 37 statistical features, and they quantified the 6 traits, and they used the Fisher's discriminant analysis. What is the discrimination ability of each feature they have done, and classification. These two models they have used, Fisher's discriminant analysis and SVM classifier. They have seen that SVM classification has given 90% of the accuracy. So this is one aspect of the how the image analysis and deep learning algorithms helps the researchers. Here also they have taken 28 rice varieties. They have taken the size, shape, and central parenchyma, and they use the same flatbed scanner with 600 dpi images, and they have taken the 11 parameters. They have done the manual and image-based measurements, and they have compared the what are the manual readings and how much it is the software, or they developed a software for this, so that whatever new variety comes, and they can scan immediately and see the comparison. So here is the comparison of manual and software readings. And if we come out of the research, if we see what is the post-harvest or value addition aspects where we can use the this image analysis neural network, even this we can, just one example I'm giving here, that is using the image processing and ANN technique, they detected adulteration of sesame oil. The sesame oil is nothing but the til oil they call, or nugula nune. And the sesame oil is mixed with canola, and with the known portions of canola. Canola is the mustard oil and sunflower oil. And the images were taken with the simple camera with this around 500 pixel resolution. And so to diagnose the mixing of the sesame oil with other oils, total color. So they mounted the so by vertical mounting they have taken the pictures, and 12 color features were extracted from the images, and they have done the ANN model by using this 12 attributes, and they compared these different ANN models. So they found that this 12, 6, 7, that means 12 features and 6 hidden layers and 7 nodes, I think. And for the sunflower mixing oil, and another 12, 10, 7 was chosen for the detecting the adulteration of the edible oils. So what I would like to say is, when adulteration can be detected by using this image analysis and using deep learning techniques. So another, this is apart from this image analysis and deep learning techniques, nowadays these drones or unmanned aerial vehicles, they're very much popular, become popular in the agriculture sector also. This is one experiment they have conducted, and they have standardized the protocol by the Professor Jayasankar, Telangana State Agriculture University, that is our state agriculture university. They have done for the crop protection for the safflower. This was done in Tandur Agriculture Research Station, and what the drone model they used is agricopter, and they have 4 nozzles, and all these standard operating protocols they have devised, like it can spray volume 40 liters per hectare. What should be the flight speed, and for what are the chemical or pests and chemical formulations they should use, and they have already checked about the phytotoxicity, whether this spraying by aerial, whether it is giving phytotoxicity, means the plants will toxic to the plants. So whether it is disturbing the another beneficial, like apart from the pests, there are many other natural pests will be there that will be helpful, like coccinelles, spiders. All these are helpful for the crop also. They are beneficial insects, they call. This helps in the eating up of the pests and scraping up the diseases and all. So all these protocols they have experimented and developed. And they even we can see spraying of the pollen in the fields. Like this is one UAV. Here they will keep one sprayer which contains soap water and pollen, because nowadays pollen like bee helps in the, like honeybees helps in the pollen distribution, pollen dispersion for fruit setting or seed setting. But nowadays these honeybee populations are coming down, are drastically reducing. So the seed setting will become difficulty, that leads to the lower yield. So what they are doing is they are mixing the pollen of the crop and spraying over the fields. So these UAV vehicles also are helping for pollen in the field, so that seed setting will be increased, and also that leads to the higher optimum yields. So these are some utilities apart from the taking images and are deploying the DL models into the drones or UAVs for taking the images and giving the advisories. Other are spraying the pesticides, fertilizers, and even for spraying the pollen. These drones are used in the agriculture. And one more, the recent technology, is blockchain technology. There are several examples. Also, they are attempting in the agriculture also. Here are some cases, some blockchain technologies. What they used, like they used the Ethereum platform mostly, or some Hyperledger they used. The final application they made into web applications. Mostly they used for the either crop insurance. This using this blockchain technology, we can trace, like many frauds will be happened in the crop insurance. Like the farmer, they tell I'll take up this crop, and they take the loan, or they take the insurance, but they grow some other crop. So if you develop a blockchain technology and trace what is the farmer's what crop he has taken, and but this helps the insurance companies to trace back whether he has taken the same crop what he has intended to take while insuring, or it helps in the banks, whether for giving the loans, whether we can trace back the all the history of that particular field. So these are the some applications in the agriculture to make the agriculture as a smart agriculture. So in conclusion, I can say that agriculture is highly dynamic and weather dependent, and whatever the expression of the object of interest is highly variable and difficult to capture entire variation. Usually what we will be doing is we will take the small training and test data due to time consuming nature of the, because getting the images and ground truth data acquisition, it takes lot of time, even manual labor, and accuracy point of view, it is very difficult. Even in the image acquisition, there are difficulties in capturing the image. There may be illumination in the fields, shadowing, crowding, and there are some errors in the feature extraction due to these images, and we have to test several models for obtaining the maximum accuracy. And finally, whatever model we developed, that should be translated into ready to use application, and it should be used by the stakeholders. Then only the whatever efforts we are taking will see the light of the day. So, as I already told, the data acquisition is the most crucial, and it is the biggest aspect in the journey. So, before planning the experiment, you have to make sure that you have to discuss with the domain knowledge experts what data should be required for your model, and how to collect, how much to collect, how many to collect, and what is the all aspects should be taken care of, so that the required data we have can be acquired. And the major time you should take in the data acquisition. After that, the data processing, model development, and application won't take much time, because you have already the experience, or you have knowledge, domain knowledge. And another aspect is taking into the creation of the awareness, whatever technology you developed, and you have to create an impact on the farmer's livelihood. So whatever projects or research work you are doing, it should show an impact on the farmer's livelihood. Then only the agriculture growth will be visible, and farmers' drudgery or farmers' time saving can be happen. So whatever technology you are going to develop, you should keep in mind that should be sustainable, scalable, and economically feasible and easy to use. So with this, I conclude my presentation. Thank you one and all for patience listening. And these are some of the literature or references I have used in my presentation. Thank you one and all. I'm done, madam.
Thank you very much, madam.
Thank you, ma'am.
Thank you, ma'am.
Shall we go for the question and answer session, ma'am? We'll ask the participants if they are having any questions. They can just raise their hand, so we will unmute them. Or you can use participants. Kindly raise your hands if you have any questions. Or you can chat in the chat box. I request the participants, if any questions, kindly raise the hands. Or you can provide your queries in the chat. Yeah.
Good evening, madam. Hello.
Yes, sir. Sharda ma'am, are you available? Hello.
Hello.
Yes, sir. 1 second. I'll just connect, ma'am. Sir, please wait for 2 minutes. Ma'am is joining. She, like, due to some technical problems, she couldn't catch you.
Okay, madam. Okay.
2 minutes, she's joining.
మాట్లాడుతున్నాం.
Sir, you can.
Ma'am, am I audible?
Yes, ma'am, you are audible. Sir, you can share the talk to ma'am directly.
Okay, good evening, madam. So I'm Dr. Mani, madam.
Okay. Yeah, tell me.
So what is the current status of agriculture, madam, in India?
Current status in the sense you need actually the food grains production was higher for 20% higher from the last 5 years. It is around 315 million tons. The as a means we are having the buffer stock for the rice and wheat. Sufficient production is there. But some other crops like oilseed crops, we are having because we are our vegetable oil imports are nearly 80,000 crores. So we have to be concentrate on the oil seeds production. But we are trying to make aware of the farmers that to go for the alternate crops than the rice and wheat, because they are very much used to the rice and wheat growing because that is our staple food. Even our Telangana government, it has given the what crops they should grow for each region. Is that your is the question? I answered this.
Okay, madam. Madam, one more doubt question.
Yeah.
So India in hunger index is 100 plus, madam. So will you able to reduce with help of these technologies?
We can say means it should, lot of effort should be taken through the research side, the government side. Basically, what is the major lacuna using these technologies is good data. We should build up a good data ecosystem to collect the data. A good ecosystem should be developed. We are having like weather data, we are having and it is in bits and pieces, but we are not having the data in a continuous manner. So it is very difficult unless the researchers like agriculture side and your domain side should come together and first make a good data ecosystem. Then we can go for the developing the models and reaching the farmers. And whatever models we have developed, it requires lot of time, energy, and the money also, because these are all high-end technologies, and it requires lot of computational effort and all. So to reach to the farmers, our farmers are very small and marginal. Unlike in the other countries, they are large farms. There will be the large farms, and they can afford the these high-end technologies, and they can bear the cost of these technologies. But in the small and marginal farmers, they need a very simple solutions to reduce their labor charges, or to reduce their to get the awareness about the pests and diseases. So it is a sort of I cannot say it is impossible, but it takes a longer time compared to the other countries. Means if we go into the real practical situation, but it is not impossible if we go in a systematic manner.
Okay, madam. Thank you.
Ma'am, there is a question in the chat box from Sandeep Babu. He says that, ma'am, my question is, what are current agricultural issues?
What are the current agriculture issues?
Yes.
All I explained is the different issues I have explained in the crop cultivation. The major issue is pests and diseases. Lot of losses we are occurring, and the simple sowing methods also requires a lot of efficiency. If you can fabricate some sort of a small machine which can be afforded by the small and large farmers. So all these are the issues to be addressed with our latest technologies. Whatever I discussed, like sowing time or identifying the weeds, getting advisory for the pests and diseases. All these are issues that can be addressed.
Thank you, ma'am. There is one more participant who has raised the hands. Kindly unmute him. Sir, please unmute him.
Am I audible, ma'am?
Yes, sir, you're audible. Please continue with your question.
Good evening, ma'am. Very nice presentation. I want to learn one thing, that deep learning technique you have discussed. So basically my research area is soil. So deep learning requires some images, and it is very comfortably we can take from crops. But for soil, how we can apply deep learning techniques?
For soil, can you repeat your question, please?
Yeah, ma'am. Actually, in my PhD, I worked in machine learning techniques in soil application. In IRI, I did my PhD.
Okay.
Then I want to ask that for deep learning technique, I want to apply in soil for nutrient estimation. So is it possible, ma'am, to apply deep learning techniques in soil?
Yeah. You can take the different types of soils. Like one example I have given, they have used different fertilizers. Different amount of fertilizers you can apply in the soil. Before that, you have to take what is the soil health condition, what is the soil nutrient status before applying your treatments. Okay. And if you are going for the image analysis, you take the images for the different soils with the different treatments like nitrogen, different nitrogen doses or something like that, or NPK as a like with the RDF as one treatment, and the incremental of RDF. Like that, you can take the different treatments and take the images of the soil, and you take different soils also, so that with the image analysis you can extract the features. Suppose if you are applying 150 percentage of the RDF, you will get definitely different color or different RGB values for that. So you can get the images of the different soil, different treatment plots, and take that features, extract those features like RGB values, and so many other features will be there. Textural factors like you can Jenkins features are there. There are Horlicks features. So many statistical higher order movement features are there. Those features you can, like more than 100 200 features you extract from the one image, like texture, color, and other even the soil properties. You can use that as attributes and develop a deep learning model. And then from the after prediction, you can get which soil with the which treatment, what are the soil status. I hope I have cleared.
Yes, ma'am. Thank you, ma'am. And one more doubt, that which software will be best for deep learning application?
There are like AlexNet, already developed models are there, like AlexNet, GoogleNet, Even I am from ISRI, and ISRI people they are now using, they are developed spike segment using. You are from IRI, you are telling. In Phenomics lab, they have taken the data, like they have counted the wheat grains, like their Phenomics have the large number of what you call treatments and experiments. They have collected all those images and they have developed a spike segment. Like that, so many, we can develop our own networks. So they use Python, TensorFlow, or you can use the already built models like I told you, AlexNet, GoogleNet, Microsoft Azure. They have developed so many models.
Is it free, ma'am? GoogleNet or AlexNet, is it free?
Huh?
GoogleNet or AlexNet, is it freely available or?
Is freely available, you are telling?
Yeah.
That I have not used. I think the Raka Metal, I think they can be available as academic purpose. Dr. Raka, madam?
Yes, ma'am. Sir, it is available, but not to the higher extent. It will support only basic models. If you have to work with large amount of data, then you can take TensorFlow on a monthly basis. There are some dollars that you need to pay for the experiment. Monthly basis, you can hire it on a Google. You get it in the Google in your account only. So anyways, we have this practical session. At that time, definitely we will show you how to work on TensorFlow. And there is a field trip where we will go to IIR and ma'am will be physically available and she will help us to address all the queries.
Thank you, ma'am.
Yeah, thank you, sir. Any further questions can raise their hands or can put it in the chat box. So this FDP is 1 week online and the second week will be offline, which is completely practical, where you will do hands-on sessions by using different tools. In that one session is on deep learning, where we will explain you about the TensorFlow architecture. Okay, so if there are no more questions, I request. If there are no more questions, yeah.
Ma'am, shall we go with further proceedings?
Yes, sir, please.
Okay.
Thank you, ma'am, for the wonderful presentation.
Ma'am, please give this virtual memento to our speaker.
Yeah, ma'am, please take as a token of appreciation. Your speech was so valuable and enriched in different areas of agriculture. Thank you so much. And there is a certificate also from our side. Virtually, we are present. When I meet you physically, definitely will hand over this to you. Thank you so much for sparing the time and giving enlightenment to the participants. It was very nice speech. Now I request Subramaniam sir to continue with the vote of thanks. Then we will end up the session. Thank you, sir. Thank you, ma'am. Thanks a lot.
Okay.
Thank you. Thank you very much.
Ma'am, I think you can see your certificate, no?
Yeah. Thank you very much for your certificate.
Thank you very much, ma'am.
Oh, thank you.
Madam, thank you very much. On behalf of KL University Hyderabad, we would like to thank AICTE ATAL FDP for giving opportunity to conduct this FDP program. And thank you, Dr. Chindili Sharda ma'am. Really, you have given an excellent presentation, starting from the farming cycle of agriculture. Personally, I understood it starts with land preparation, sowing, irrigation, fertilizer, pest management, and harvesting. And you have given a wonderful abbreviation for smart agriculture, self-monitoring, analysis, reporting, and technology usage. Thank you once again, ma'am, for giving an excellent presentation and excellent lecture. This 1.5 hours, really, personally, I got 15 years of information. Thank you very much, ma'am. On behalf of our team, once again, we are thanking you, ma'am. Thank you for giving an excellent lecture and presentation. Thank you very much.
Thank you. Okay, thank you. Shall I leave?
Yes, ma'am. Thank you so much.
Thank you.
Thank you, participants, for being here. Tomorrow also we have a valuable session from CDAC. Mr. Sam Santosh, he will give you a good exposure on agriculture aspects using IoT. Thank you so much for attending. Have a good night and have a great day. Thank you. Sir, can we end up the session?
Yes, ma'am.
Yeah.
And tomorrow, please, participants, please join exactly at 7 p.m.
Yeah. Thank you. Thank you, sir.
Thank you.
Thank you, Sandeep, for hosting it.
Sandeep sir, you can close the session.